Hello dear friends, welcome back to MACSGATE. We are learning probability and statistics. Probability and statistics is a topic in engineering mathematics which is common to all branches. And for data science and artificial intelligence students, the syllabus for probability and statistics is more. So because of that, we divided this probability and statistics into three parts. The first part is common to all branches. Okay. So if you are belonging to any branch, so up to this, probability distributions, it is common to all. So we are doing, problems on dependent and independent events. On Friday, I started this conditional probability, and yesterday we discussed about multiplication theorem. It's a continuation of that. Okay. Of course, the formulas are very basic formulae, so you can directly understand, because in probability, the problems which we generally see are, or the experiments which we generally see are throwing a dice, okay, or tossing a coin. These kind of experiments which you regularly know, so you can easily understand. So let us take up some problems on independent and dependent events. Of course, the concept here we are going to use is concept of conditional probability and multiplication theorem only. Okay, so first we start with problems on independent events. The first question: the probability of getting a head in a single toss of a biased coin is 0.3. That is, probability of getting heads is how much, sir? 0.3. So because it is a biased coin, the probability of head and tail are not equal. So probability of head is 0.3, means probability of tail is 0.7. Okay. Now the coin is tossed repeatedly till a head is obtained. So till you get head, you are tossing the coin again and again and again. If the tosses are independent, generally the tosses are independent, because of that head, tail in different tosses are independent. Am I clear? If the tosses are independent, then the probability of getting head for the first time in fifth toss is what? What is probability of getting head for the first time in the fifth toss? What do you mean by getting head for the first time in the fifth toss? The first four tosses you should get tail. So that is the situation. So this is what you are looking for. So this is what we call it as your favorable situation. So here, what is probability of getting tail in the first toss, my dear friends? 1/2. Probability of getting tail in the second toss, 1/2. Tail in the third toss. Be careful. It is not a fair coin. It is a biased coin. So probability of getting tail in the first toss is not 1/2, it is 0.7. Tail in the second toss is 1.7. Tail in the third toss is 0.7. Tail in the fourth toss, you want to get tail in the fourth toss, which is 0.7, and probability of getting head in the fifth toss is 0.3. So you want to get head for the first time in the fifth toss, means so you want this to happen. That is, tail in the first toss, tail in the second toss, tail in the third toss, tail in the fourth toss, and head in the fifth toss. And what is probability of this, my dear friends? 0.7 power 4 into 0.3. Multiply to get the required answer. Am I clear? The next one. A player throws a ball at a basket kept at a distance. So there is a basket, so he is throwing a ball. The probability that the ball falls into the basket in a single attempt is 0.1. That is, in a single attempt, when he throws, the probability that the ball falls into the basket is 0.1. Okay. So let us call that as success. So what is probability of success, my dear friends? 0.1. And what about the probability of failure or non-success, or probability that he will not able to throw the ball in the basket is 1 minus 0.1, that is 0.9. See, the player attempts to throw the ball twice. So how many times he throws? Twice. Considering each attempt to be independent, very good, the probability that this player puts the ball into the basket only in the second attempt. So what is the probability that the player puts the ball into the basket only in the second attempt? Okay. Ball in basket only in second attempt. So what happens? What is your favorable situation? So the favorable situation is, of course, he throw the ball 2 times. first time and second time he should get the success. So first time is not able to throw the ball in the basket, and these two are independent event. And what is probability of this? 0.9. And what is probability of this? 0.1. 0.9 into 0.1 is 0.09. So that is the answer. Am I clear? Next one. A digital communication system transmits a block of n bits. So a digital communication system transmits a block of n bits. So we are having 1, 2, 3 and so on, n bits. The probability of error in decoding a bit is alpha. The probability of error in decoding a bit. So when you are decoding a bit, the probability of error is alpha. So probability of error is alpha. Am I clear? So what is probability of no error or error complement, you can say, which is 1 minus alpha. This is for any bit. Probability of error in decoding a bit, whether it is first bit, second bit, third bit or any bit. So let us, instead of calling it as generally, let us make it like, probability of, okay, error in decoding ith bit is also same. So for any bit it is same. So what is probability of error in no error in? So no error in, that is complement of error in decoding ith bit is 1 minus alpha. This is same for where I is ith bit. So this is the story for ith bit. So for first bit also story is same, second bit also story is same, even for nth bit also story is same. Now the question is, the error event of each bit is independent of error event of other bits. So all the bits are independent, that is error in getting any bit is independent of error in getting any other bit. That is also mentioned. The received block is declared erroneous. So you got a block of n bits. So here you send a block of n bits. So it is mentioned that it is erroneous. Okay. And the received block is declared erroneous if at least one bit is decoded wrongly. Of course, this is how he is mentioning that result, sir. He is saying that the block of n bits, we call it as erroneous if at least one bit is decoded wrongly, or at least one bit decoded wrongly means erroneous bit, that is at least one bit is erroneous. At least one bit is erroneous. At least one bit is erroneous. Okay. Or there is the error in decoding at least one bit. There is error in decoding at least one bit. You can write in the same statements, error in decoding at least one bit. See, what do you mean by error in decoding at least one bit, sir? Okay. So error in decoding at least one bit means first bit error or second bit error or nth bit. At least one means this is the meaning. At least one means this is the meaning. And what is he is asking? The probability that the received block is erroneous. See, the probability that, okay, let me clear this and write. Probability that the received block is erroneous. When a received block will be erroneous, sir? If at least, or you can say this, error in decoding at least one bit. If there is error in decoding at least one bit. If there is a error in decoding at least one bit. What do you mean by that? Error in decoding the first bit, or error in decoding the second bit, or and so on, error in decoding the nth bit. So this is the answer which you want. But if you want to solve this, this is a very lengthy process, because if you are having just union of three events, It is like, probability of A plus probability of B plus probability of C minus probability of 2 combinations with a minus sign, then probability of 3 combinations with plus sign. So it is a very lengthy process. We are having a very beautiful formula, that is probability of at least one can also be found like error in decoding none. From 1, if you remove error in decoding none, then you are going to get at least 1. If you want at least 1, which is 1 minus none. So what is probability of error in decoding at least 1, which is 1 minus probability of error in decoding none of the bits. None of the bits. So what do you mean by that? This is 1 minus probability that there is no error in decoding the first bit, and there is no error in decoding the second bit, and so on. There is no error in decoding nth bit. So what is it? 1 minus, because they are the independent event, probability of intersection is nothing but product of the probabilities. Error in decoding, there is no error in decoding the first bit, into probability that there is no error in decoding the second bit, and so on. Probability that there is no error in decoding nth bit. 1 minus, and as I told you already, EI complement is 1 minus alpha. So it is 1 minus alpha for every fellow. 1 minus alpha, and so on, 1 minus alpha. How many times? N times. So it is 1 minus alpha whole power n. So what is the answer for this, sir? 1 minus alpha whole power n. So the correct answer for this is option C. So this is the gate question, my dear friends. Is that clear? See, whenever the events are independent, whether you are having 2 events, 3 events, even 10 events or 100 events, we'll see little later. Even if you are having infinitely many events, the answer will be the same. Very simple, product of the probabilities. You can easily find it. Okay. Now let us take one interesting problem. This type of problems you can see every now and then in gate examinations. Probability of A union B is given. Probability of A is given. If A and B are independent, A and B are independent, then the value of A into probability of B is what? See, one very common mistake which people do is, when we say independent, they feel that probability of A intersection B is 0. You will be put in nearest to jail, Babu. This is wrong. That is when they are disjoint. Disjoint is different from independent, Babu. Disjoint means events do not have any outcomes in common. Independence happens if one event does not affect the other event. These are the independent events. They are not disjoint. These are the independent events. What do you mean by independent events, Babu? A and B are independent means probability of A intersection B is probability of A into probability of B. Please note this point, Babu. Okay, thousands of students come to me every time when I teach for this particular property. Okay, so this is called misunderstanding, and a very, very common misunderstanding. Okay, so I answered this many times while I was teaching. Am I clear? So general common mistake is they assume independent means immediately they think about disjoint events. Independent is different from disjoint. Please note that. Okay. Now this is the idea. Probability of A intersection B is probability of A into probability of B, because they are independent. Here A is given as, probability of A is given as 0.4. Probability of B you do not know. Let us call it as some X. So what is probability of A union B according to the formula, which is probability of A plus probability of B minus probability of A intersection B. Here you know probability of A union B, which is 0.6, and you know probability of A, which is given as 0.4. Probability of B is not known. We need to find it. Let us call it as X. Now what is probability of A intersection B? It is probability of A into probability of B. Of course, you can directly write, or you can take one more step. So 0.6 is equal to 0.4 plus X, and it is 0.4 into X. So it is 1X minus 0.4X is 0.6X. So it is 0.6. So what happens? 0.6X is equal to 0.6 minus 0.4. That is X is equal to 0.2 by 0.6, which is nothing but 2 by 6, yani 1 by 3. Maybe 0.33 up to 2 decimals, my difference. Sometimes they'll ask you up to 2 decimals, what is the answer? That is the answer. This is one of the very interesting questions, sir. They'll ask you this very regularly in GATE examination. Okay, that is some B event may not be given, only A is given, still you can handle it because A and B are independent. So probability of A intersection B is probability of A into probability of B. See the advantage of independent events. When the events are independent, you don't need much information, sir. See, in the last class, I given one very beautiful example towards the end. If I only know probability of X, probability of Y, probability of Z, I shown you how many questions we can answer if the events are independent. Okay, how many questions we can easily answer if you just know the 3 probabilities. That is the advantage of independent events. Of course, it depends on the problem or the type of events. Okay, if the events are independent, you can apply the results, properties. That is the idea here. Now, this is one very interesting formula from, algebra, geometric series. Okay, you all know, arithmetic progression, geometric progression, or arithmetic sequence and geometric sequence. What is arithmetic sequence, sir? For those who do not know, I quickly give you what is arithmetic sequence. It is the arithmetic sequence A plus D, A plus 2D, and so on. That is, every time a common difference is added. And what about a geometric progression ya to geometric sequence? This is the geometric sequence. Every time you are multiplying with a common ratio, that is called R. AR square, AR cube, and so on. Now here the nth term of the geometric sequence is given by AR power n minus 1. But what is very important is sum to n terms. Sum to n terms of a geometric series. So when you add them, that sequence becomes a series. Sum to n terms is given by A into 1 minus R power n by 1 minus R if R is smaller than 1. A into R power n minus 1 by R minus 1 if R is greater than 1. Okay. And one more very interesting is sum to infinite terms, we can find it. Sum to infinite terms of a geometric sequence if the value of R is between minus 1 to plus 1. We simply write mod R less than 1. In this case, the formula is A by 1 minus R. So we can also find sum to infinite terms if the common ratio is between minus 1 to plus 1. Am I clear? In that case, it is possible, my dear friends. So that is what it is. Sum to infinite terms of geometric series is given by A by 1 minus R, where minus 1 less than R is less than 1, or mod R is less than 1. I require this particular formula, my dear friends. Okay. For example, if I am having, say, 1 by 2, 1 by 2 into 1 by 4, 1 by 2 into 1 by 4 square, 1 by 2 into 1 by 4 cube, and so on. Here A is 1 by 2. And what is the common ratio? Every time I am multiplying with 1 by 4. So what is the formula sum to infinite terms of this? A, that is 1 by 2 by 1 minus R. What is R? 1 by 4. So this is 1 by 2. In the denominator it is 3 by 4. 3 by 4 in the denominator can be written as 4 by 3. So what is the answer, sir? 2 by 3. So we can handle problems like this. That is about sum to infinite terms. We are going to get such type of geometric series where we need to find sum to infinite terms. I told you, when you are having independent events, whether you have 2 events or combination of 3 events, even 30 events, even infinitely many events also we can handle, because when the events are independent, probability of their intersection is product of their probabilities. That is one of the very beautiful property. Not only that, when the events are independent, not only the events, happening or non-happening of the event does not affect happening or non-happening of the other events. So A, B are independent, then A complement B are independent, A, B complement are independent, A complement B complement are also independent. So this is the advantage, right? So let us take up some problems. A fair coin is tossed till a head appears for the first time. So you are tossing a fair coin, okay? If it is head, you stop it. Otherwise, you toss again. If it is head, you stop. Otherwise, you toss. So you are going to continue this as long as you get head. Till you get head for the first time, you are going to continue. Tell me when you can get the head. You may get head in the first toss itself, or second toss, or third toss, or fourth toss, or fifth toss. So it may go indefinitely. it may go indefinitely, my dear friends. Of course, in practical situations, you may get after finite number of times, but theoretically, you can't say when you can get. You may get tail continuously. In that case, you have to toss till you get the heads. That is your actual experiment. But here, what is that you want? You want to find probability that the number of required tosses is odd. That is, you want to get head in odd numbered toss. That is, in the first toss you want to get head, or in the third toss you want to get the heads. See, when you get the head means the game is over. This is the game. Till you get the heads, you are tossing the coin. Okay? So either you want to get head in first toss, or in third toss, or in fifth toss, or in seventh toss, and so on. So what is that you are looking for? What is that you are looking for? And before that, let me identify the events, because we are tossing a coin. So here we are having a fair coin. So probability of head is 1 by 2 in each toss, and probability of tail is 1 by 2 in each toss. In each toss, probability of head is 1 by 2, probability of tail is 1 by 2. And what is the favorable situation we are looking for? What is the favorable situation? See, actually head can happen in the first toss, second toss, third toss, any toss. But what you are looking for? You are looking for number of required tosses is odd. So we are looking for number of tosses required is odd. That is, you want to get head in the odd numbered toss and you want to stop the game. So what is the favorable situation for this, my dear friends? You may get head in the first toss itself, or you may get head in the third toss. You may get head in the first toss, or you may get head in the third toss, or you may get head in the, because odd numbered toss means either first toss or third toss or fifth toss or seventh toss and so on. It goes up to infinity. But here I want you to understand, head in the first toss means okay, but head in the third toss for the first time means the previous two tosses you should get tail. Because if you get head anywhere, you have to stop there. That is the idea. What about head in the fifth toss means the first four tosses you should get tail. And this is what we are looking. So the probability that the number of tosses required is odd can happen either this way or this way or this way or this way. That is, the probability that the number of required tosses is odd can happen in all these disjoint ways. So probability of that particular event is probability of union of these events. Because they are all disjoint events, probability of disjoint events is simply nothing but sum of the probabilities. So you just need to find probability of this plus probability of this plus probability of this and so on. So we are just getting probabilities and we are going to add them, my dear friends. Because all these are disjoint events. That is, getting head in the first toss or tail head. These two are disjoint events. There is nothing common between them. Am I clear? Because head here, tail head. So that never matches. So they are all disjoint events. Am I clear? Now what about probability of head in the first toss, my dear friends? That can happen in 1 by 2 ways. Tail in first toss, tail in first, second toss, head in third toss. 1 by 2, 1 by 2, 1 by 2 because they are independent. What about this? 1 by 2, 1 by 2, 1 by 2, 1 by 2 and 1 by 2 and so on. So here I'll just rewrite this like 1 by 2 plus. See here 1 by 2 I want to take common, sir. I want to take common. So what happens? Okay, let us take 1 by 2 common and see what happens. If you take 1 by 2 common, here 1 remains. Here 1 by 2 square, that is 1 by 4. And it is 1 by 2 square, that is 1 by 4 whole square. The next one automatically 1 by 4 cube, because 1 by 2, 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 3 times. So that is 1 by 4 whole cube and so on. And it is an infinite geometric series. Obviously the common ratio here is 1 by 4, which is between -1 to +1, less than 1. Okay, fine. That is very good. So we need sum to infinite terms for this. What is sum to infinite terms formula? A, here A is 1, R is 1 by 4. A by 1 minus R, that is 1 minus 1 by 4, which is 1 by 2 into 1 minus 1 by 4 is nothing but 3 by 4, which is nothing but 1 by 2 into 4 by 3, which is 2 by 3. So probability that the number of tosses required is equal to odd is given by 2 by 3, my dear friends. So that is a probability. Is the idea clear? Okay, here those events are shown. You can see either they can happen this way or that. Is that clear? Anyway, we already solved it. Next one. Two players A and B alternatively keep rolling a fair die. So there is a single die. A, B are playing. They are alternatively keep rolling a fair dice. The person to get 6 first win the game. So what is the game? A, B start the game. So one of the person starts. If he gets 6, he wins. Game is over. Otherwise, B get the chance. B will throw, okay, or roll the dice. If he gets 6, game is over. Otherwise, again A get the chance. He rolls. If he gets 6, game is over. Otherwise, B will get the chance. He rolls. If he gets 6, game is over. So this will continue till anyone gets 6 for the first time. This is the game. See, we need to understand that experiment or the game. Then what is that you are looking for? That favorable situation you are looking for. If you understand, this type of problems are very, very simple. So two players A and B alternatively keep rolling a fair dice. Very good. The person to get 6 first wins the game. Given that player A start the game, probability that A win the game. So here what is important is we need to identify the events. So here either A gets 6 or B gets 6. So let us call this event A as A gets 6. And let us call the event B as B gets 6. And what about probability of A gets 6, my dear friends? Because it's a fair dice, 1 by 6. 1 by 6 is the probability that A get number 6. Then what is probability that A does not get 6? 1 minus 1 by 6, which is 5 by 6. And what about probability B gets 6 when he rolls a dice? 1 by 6. And probability that B does not get 6 is 1 minus 1 by 6, that is 5 by 6. So these are the events, the probabilities which are required to solve this problem. Now, here what happened? A started the game, probability that A wins the game. Okay. What is the probability that A start and A wins the game? That is what we are looking for. So what is the favorable situation, my dear friends? What is the favorable situation? So you want A to start and A to win the game. That is, A should get 6. Am I clear? Winning the game means whoever gets 6 first wins the game. Now, it may happen when first time, because A started, first time itself A start and A win the game. I am writing A as A gets 6. Game is over. Otherwise, when again A will get the chance, first A rolls the die, he does not get 6, then B get the chance. Suppose if B get the 6, game is over, but you want A to win, so B also does not get the 6. Again A get the chance. That is, A again get the chance in third turn, third roll. And here you want A to win the game. Either in the first toss, he should get A, or second time when he get the chance, he should get 6, or he should win. Means what happens in the first two tosses, because first A started, he should fail, then only chance is given to B. B also should fail, otherwise game will be over there itself. So B also fails, then A wins. Or what about this? Again A gets chance in the fifth run, because alternatively either he get in the first he rolls, or third time he roll, or fifth time, like that. So A wins fifth time. Then what happens? First roll A failed, second row B get the chance, he fails, again A get the chance, he failed, again B get the chance, he failed, then A wins, and it continues forever and ever. That is the story. Am I clear? Now what about the probabilities, my dear friends? What is probability of A, sir? Because they are all independent events. What is probability of A getting 6? 1 by 6. A not getting 6, 5 by 6. B not getting 6, 5 by 6. A getting 6, 1 by 6. A not getting 6, 5 by 6. B not getting 6, 5 by 6. A not getting 6, 5 by 6. B not getting 6, 5 by 6. A getting 6, 1 by 6, and so on. Come to infinite terms. and you just need to identify. I can take 1 by 6 common, so that it is 1 plus 5 by 6 into 5 by 6, that is 25 by 6, 36. Here 5 by 6 into 5 by 6 whole square, that is 25 by 36 whole square, and it goes here. What happens? A is 1 first term and common ratio is 25 by 36. So what is the formula? A by 1 minus r, that is 1 by 1 minus 25 by 36. Is the idea clear? So what happens? 1 by 6. So what about this, sir? So this is nothing but 11 by 36. 1 by 11 by 36, which can be written as 36 by 11, which is nothing but 6 by 11. So what is the probability that A starts and A wins the game? A start and A win the game. What is the probability? 6 by 11. Suppose if I ask question, A start and B wins the game. If you are watching later, please answer this. Okay, I'll be keeping it open. You can write in comment box. Am I clear? B start the game, A start the game, but B wins the game. A start, but B wins the game. So here it is like, A complement B, or A complement B complement A complement B, and so on. For this you want. See, it is actually complement of the previous event. So it is actually 1 minus 6 by 11. So the answer here would be 5 by 11. Directly you can do it, or you can try by this method, sir. Alternate method. Please try this. Is the idea clear? You can try by this method, or you can try by this method. Any method will work. Hope you understand. Now, two players A and B alternatively throw a pair of dice. Here not single die, two dice they are rolling. A, B only, two members A, B only, but they are throwing pair of dice. Right? Very good. A wins if he throws 6 before B throws 7. It's game like this. So when A will win, sir? When he get 6. Here 6 means sum, because they are rolling pair of dice, na? So what do you mean by A event? A get sum is equal to 6. And what about B event? B get sum is equal to 7. Please note that. Now here A wins if he throws 6 before B throws 7, and B wins if he throws 7 before A throws 6. That is a game. So both are having chances. Suppose if A start, if he rolls, if he gets 6, game is over. Otherwise B get the chance. If he throws 7, sum 7, that is sum of the two values which on the dice, the sum equal to 7, then he wins. Otherwise again A get chance, story continues. And here A begins, then chance that A is winning. Before directly getting into the favorable situation, we need to identify the probabilities. See, in the first problem, directly head probability of head is 1 by 2, probability of tail is 1 by 2, very simple. But here, first of all, you need to identify the events and their probabilities. So what is probability that A gets 6, sir? When you roll 2 dice, what is probability of getting sum 6? 5 favorable out of 36. What is probability that B gets 7? That is, what is probability of getting sum is equal to 7, which is 6 upon 36. And we also need to find A complement, which is 1 minus 5 by 36, which is 31 upon 36. What is probability of B complement, sir? You can write it as 1 by 6, then it is 1 minus 1 by 6, yani 5 by 6. So these are the required probabilities. So before proceeding further, always find required probabilities. Now, what is that you want? What is that you want? Probability that A start and A wins. Okay. So what happens? What is the favorable situation? The favorable situation is, because you want A to win, first time A directly wins, or alternative na, again third time A get the chance, then he wins, or A get the chance fifth time, then he wins, and so on. What do you mean by this? Because third time A is winning means first time A already got the chance, there he failed. Then B got the chance, he also should fail. Then only A will get the chance. Here A fails, B fails, A fails, B fails, then A get the chance. And the story continues like this. And you know the probabilities, my dear friends. What about probability of A? 5 by 36. A complement is 31 by 36. 31 by 36. B complement is 5 by 6. And A is 5 by 36. Please be careful, it is 5 by 6 and it is 5 by 36. Generally in such cases people do mistakes, sir. Please be careful. And here it is 31 by 36, 5 by 6, 31 by 36, 5 by 6. And A is 5 by 36. And it continues. Actually here 5 by 36 is common. So what is not common, sir? This particular portion. Because this portion, it is squared here, cubed here, and so on. So it is 31 into 5 by 36 into 6. 36 sixers is 216. It is 155. Square of that fellow. 155 by 216 whole square. And so on. Same story. A is 1. Common ratio is 155 by 216. Correct? Okay. So now it is 5 by 36. A by 1 minus R, that is 155 by 216. So that is 5 by 36 into 216. So what happens? 45, 55, 61. Is that clear? 216 minus 155. 61. 36 sixers. 30 upon 61. So that is the required answer. Is the idea clear? Hope you understand. So this is one more problem. A pair of dice rolled again and again till a total of 3 or 5 is obtained. So here it's not about A, B, sir. You are alone playing. Okay. So you take a dice, pair of dice, 2 dice. You roll till you get a total. Total means sum. Till you get a sum of 3 or 5 is obtained. So what is the game? First of all, you take the 2 dice, you roll them. If you get 3, game is over. Otherwise, don't again directly throw it, or don't again directly roll the 2 dice. You just see whether 5 happened or not, because you are going to stop for 3 or 5. For sum is equal to 3 you stop, for sum is equal to 5 also you stop. Please try to understand this point carefully, sir. This is a very common sense, because this game you stop with sum 3 or sum 5. If you get sum 3, happily stop it. Otherwise, check whether it is 5 or not. If it is 5, then also you stop. So for sum 3 you stop, for sum 5 also you stop. Am I clear? So here let us call the event as getting sum 3 and B as getting sum 5. What is probability of getting sum 3, sir? Sum 3, 2 cases out of 36 cases. Sum 5, how many cases, sir? Sum 5, 4 cases out of 36 cases. For sum 5, if you remember the table which I given, that is the story. But what is very important here is, when you roll the dice again, when you roll the 2 dice again, see, if 3 you stop, for 5 also you are going to stop. When it is not 3 and not 5, then you are going to roll again. Okay, so what is the failure here? What is the failure event? Neither getting 3 nor getting 5. Sum not equal to 3 and sum not equal to 5, then you are going to roll again. So we need sum not equal to 3 and sum not equal to 5, because this is the important event for us, the required probability. And you know what is probability of A complement intersection B complement? Now people think about whether they are dependent or independent. Well, they think whether they are dependent or independent. See, when you roll dice, If you get sum 3, you can't get sum 5. If you get sum 5, you can't get sum 3. So here, these two are dependent event. So you can't write it as probability of A complement into probability of B complement, which is a very common mistake which people do. Many times I have seen that. People ask me with that particular question. Here the two are dependent events, getting sum 3 and getting sum 7. When two dice are rolled are dependent, because if you get sum 3, you cannot get sum 7. If you get sum 7, you cannot get sum 3. So they are depending on each other. So that product does not happen. But you know what is probability of A complement intersection B complement? 1 minus probability of A union B. And A union B is very simple to find. That is, sum is equal to 3 or sum is equal to 5. So what is probability of A union B? Sum 3, yeah, sum 5. Because sum 3 and sum 5 are disjoint events. They are dependent, but they are disjoint events. So I can do this. So which is like 2 by 36 plus 4 by 36, which is nothing but 6 by 36. So A union B is 6 by 36. So what is neither A nor B? 1 minus 6 upon 36, which is nothing but 30 by 36. You can write 5 by 6 sir, directly, or here you can write 1 by 6. So 1 minus 1 by 6, 5 by 6. Anyhow, you can get the answer. So here required probabilities are this one and this one, because you are looking for that. Now, what is that you are looking for, sir? What is that you are looking for? Okay. What is the chance of a total of 3 comes before a total of 5? Okay. What is the probability that total 3 appears before total 5? So what is our favorable situation? What is our favorable situation? See, you want to get a total of 3 before getting total of 5. See, in the first roll itself, you can get a total of 3. Total of 3 means A event. Total of 3 means A event. Now, if you don't get in the first toss, maybe in the second toss you may get total 3. But if you are moving to the second toss, means what should happen in the first toss? It should neither be 3 nor be 7. Because if it is 5 also, you stop there. So here it should be neither A nor B here. This event here, then you get A. That is, sum is equal to, total is equal to 3 in the second toss. Or this may happen in the third toss. In the third toss, you may get sum is equal to 3. What do you mean by that? In the first two toss, you get neither 3 nor 5. Second toss also neither 3 nor 5. That is A intersection B, A complement intersection B complement here. Again A complement intersection B complement here. And it continues forever and ever and forever. And you know the probabilities. See, in different, these are all disjoint events. And here, what is this probability, sir? What is probability of A here? What is probability of A here? 2 by 36. And A complement intersection B complement 5 by 6. A again 2 by 36. A complement B complement 5 by 6. Again 5 by 6. A is 2 by 36. And it continues. Here what to be taken common? 2 by 36 you can take common, so that it is 1 plus 5 by 6. 5 by 6 whole square. And so on. See, the remaining part is the regular story, my dear friends. That is 2 by 36. Now here A is 1 and common ratio is 5 by 6. 1 by 1 minus 5 by 6, which is 2 by 36. 6 minus 5 is 1. So it is 2 by 6. Yani 1 by 3. Is that clear? Right. Hope you understand. So this is the idea, my dear friends. So we just need to understand the situation properly, then any type of problem can be solved very easy. Now let us move on to the dependent events. So far the idea is clear. All the problems are clear. If you have any doubts, you can write, my dear friends. So what do you mean by dependent events, sir? Happening of one event affect happening of the other event. Happening of one affect happening of the other event. So they are called dependent events. Okay, so let us take up some problems to understand this particular situation, my dear friends. Look at this problem. A bag contains 4 white and 6 red balls. Okay, a bag contains 4 white and 6 red balls. 4 white balls are there and 6 red balls are there. Balls are drawn at random, one at a time, without replacement. So you are drawing the balls one at a time without replacement. Find the probability of getting a white ball in the third draw. You want to get a white ball in the third draw. See, my dear friends, total how many draws happened? 3 draws happened. What is the required thing, sir? You want to get white in the third draw. What do you mean by that? White in the third draw. Suppose if it is with replacement, same question if I say with replacement instead of without replacement, if it is with replacement, white in the third draw would be 4 by 10 because we replaced, so first 2 event does not affect the third event. Am I clear? So what happens? How many white balls are there? 4 white balls. Total 10. 4 by 10 is the answer directly. But here the first 2 events affect the third event. Okay. See, my dear friend, in this case it may happen that the final answer again you may get 4 by 10, but don't think that, oh, it always will be 4 by 10. Because of the number sometimes it may happen. Because of the situation sometimes it may happen, but please don't make such wrong conclusions. Am I clear? So here you want to get white in the third draw means, the first 2 draws what can happen? Because we are having white and red balls. So in the first 2 draws you may get white and white, white and red, red white, and finally red and red also. Because third draw is fixed, first two draws are not fixed. So this event can happen in the following 4 disjoint ways. So what is the favorable situation, Babu? What is the favorable situation, Babu? Please try to understand. Totally 3 draws are there. And that can happen in the following 4 ways. So white is fixed here. But the first 2 draws you may get white, 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 red, red, white. Okay, white, white already over na, so ne red, red. So we need to find the probabilities. So here let us see, here we are having 4 white and 6 red. First draw, because it is without replacement, so you need to see the situation carefully and solve the problem. In the first draw you want white, that can be done in 4 by 10 ways. 1 white is gone, 3 white remain. Now in the second draw also you want white, that can be done in 3 by 9 ways. 1 white is gone, 2 white remaining. In the third draw you want white, means that can be done in 2 by 8 ways. The next one, second situation. Originally 4 white and 6 red are there. First you want white. White can be drawn in 4 by 10 ways. 1 white is gone, 3 white remaining. Red can be drawn in, because 6 favorable out of 9 now, because it is without replacement. So 1 is gone, 5 remaining. Now you want white, that can be done in 3 by 8 ways, because 3 favorable out of 8. Or again this situation, 4 white and 6 red. Red can be drawn in 6 by 10 ways, 5 remaining. White can be drawn in 4 by 9 ways, 3 remaining. White can be drawn in 3 by 8 ways, because 3 white remaining out of 8. That is the story. Final one, red, red, white. 4 white and 6 red. Red can be drawn in 6 by 10 ways. 1 red is gone. Again red can be drawn in 5 by 9 ways. 1 more red is gone. 4 red is remaining. Next white can be drawn in 4 by 8. So that is the required probability, my dear. So if you simplify, denominator is same, 10 into 9 into 8. Numerator if you observe, so here 4 is common. That is it. 4 is common in everyone. Remaining things are changing, like 3 to 6, 6 3 is 18, 6 3 is 18, and again the last one is 6 5 is 30. So you can simplify this. 4 into, so 36, 66, 72, 10, 9, 8. Oh, it's 72, sorry. So 9, 8, 72, 4 by 10. As I told you, you may get the answer same, but that is not due to that fact, sir. Because of the numbers, it might happen. Am I clear? So here the required probability need to, because this event depends on the previous 2 events. Okay. This is the very interesting idea, my dear friends, which we need to understand. Okay. Is that clear? The next one. Suppose a bag contains 3 orange and 4 yellow balls. Bag A contains. Bag B contains 4 orange and 3 yellow balls. Bag A contains 3 orange and 4 yellow balls. Bag B contains 4 orange and 3 yellow balls. Here, see what is happened. A ball is transferred at a random from bag A to bag B. Then a ball is transferred from bag B to bag A. Then a ball is taken out from bag A. What is the probability that this fellow is orange ball? Okay. So let us try to see this. So we are having in the first bag, bag A, 3 orange and 4 yellow balls. The second one we are having 4 orange and 3 yellow balls. Okay, I am not showing complete animation, only idea I am telling you. First, what happened? A ball is transferred from A to B. So here it is, one ball is taken out without replacement for this, but that is put in the second bag. So some additional things are added to that. So even the situation or current scenario of B is changed. Now a ball is transferred from B to A. Okay. So again from B, one ball, we do not know what is that. That is taken out and that is placed in bag A. This is first draw. This is the second one. Now a ball is drawn from the bag A. Now a ball is drawn from bag A. What is the probability that it is orange ball? What is the probability that it is orange ball? This is the question. We just need to answer this. See, my dear friends, we are having total 3 draws. 1, 2, 3 draws. What is guaranteed, sir? You want orange in the third draw. See, first draw is done from bag A. Second draw is done from bag B. And third draw is done from bag A. But please note, the situation of bag is changing, keep changing, because it depends on the previous draw. Because what you draw in the second one, what is drawn in the second draw from bag B depends on what ball is placed in the first draw from bag A to bag B. So here these events are dependent events. But what is required here? You want orange in third draw. This is fixed. You want to draw orange from obviously bag A in the third draw, that is fixed. But these are not fixed. So in the first draw, you may take a orange ball and keep it in bag B, or you may take yellow ball and keep it in bag B. Similarly, in the second draw, you may take orange ball and keep it in bag A, or you may take a yellow ball and keep it in bag B. This is the idea, my dear friends. So here there are 2 possibilities and there are 2 possibilities, 2 into 2, 4 possibilities. That is how this can happen. That is, what is the probability that the orange ball is drawn in the third draw? So what is the question here? What is the probability that the orange ball is drawn in third draw? Of course, from bag A. This is the story. But how this can happen, my dear friends? So what is the favorable situation for this? What is the favorable situation for this? Let us try to understand. See, my dear friend, as I told you, here this is fixed. And of course, this is happening from A, this is happening from B, this is happening from A, this is fixed. Because there are 4 choices, let me write down the 4 choices. This is fixed, happening from A, happening from B, happening from A. This is fixed, this is A, this is B, and this is A. Or it can happen like 1, 2, 3, A, B, A, and here you want to draw orange ball. That is fixed. Now here, as I mentioned, first draw you might have taken orange and placed in bag B. From bag B also you taken orange and placed in bag A. So it may be orange, 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 yellow, yellow, orange, yellow, yellow. So we have to see 4 situations and solve the problem, my dear friends. Okay. So let me show you how we do this carefully. So for each time you need to see this bag A and bag B. So I'll be drawing bag A, bag B every time, sir, for each situation. Okay. You can call it as 1, 2, 3, and 4 situation. So first situation. Okay. So I'm just writing bag A, bag B, bag A, bag B. So initially we are having 3 orange and 4 yellow here, and 4 orange and 3 yellow. See, later on you can change these numbers and try to solve the problem again, my dear friends. Now first draw you want to take orange from bag A. What is probability of taking orange from bag A, sir? 3 favorable out of 7. But this orange is removed, so only 2 oranges remaining. That removed orange is placed here. So now here we are having 5 oranges in bag B because the removed one is placed in bag B. Now you want to take orange from bag B. What is probability of selecting orange from bag B, sir? 5 favorable out of 8. 5 favorable out of 8. So 1 orange is removed. Now 4 oranges are remaining. That is placed back into this. So here we are having 3 oranges now. We are having 3 oranges now. Now what is probability of selecting orange from bag A in the third draw? Now what is probability of selecting orange here now? 3 favorable out of 7. And that is the first situation. You need to repeat this for remaining 4 situations. 3 situations. Now second one. So here this is bag A and this is bag B. 3 oranges originally, 4 yellows originally, 4 oranges and 3 yellows originally. Is the idea clear, sir? If you are having any doubt, please ask. Is the idea clear? Now first you want orange. Probability is 3 by 7. So orange removed 2 oranges. That is placed here. So now we are having 5 oranges. Now you want to take yellow from this. What is probability of selecting yellow from bag B? 3 favorable out of 8. 3 favorable out of 8. So yellow is removed. So 2 yellow remaining. That is placed here. So it becomes 5 yellows. Now what is probability of selecting orange from bag B? 2 out of 7. Now continue this for the third situation. If you can understand without drawing also, you can directly do it, sir. I always suggest do it so that you will not do mistakes. Because you need to properly visualize, because it is a dependent event. What is happened in the previous draw affect it. You can't directly do it. You have to see what happened. Okay. So if you can directly visualize it in mind, fine, you can do it. Otherwise, happily do it like this, no problem. So here yellow, first yellow means 4 upon 7. So yellow removed, 3 yellow remaining. Now you want to take orange here, 4 upon 7. 1 orange is removed, so 3 oranges, and now it becomes 4 oranges. Now what is probability of selecting orange from this? 4 upon 7. And finally, I'll write fourth situation here. 3 oranges, 4 yellows, 4 oranges and 3 yellows. So first you want yellow, that is 4 upon 7. Yellow removed, so 3 yellows here, and yellow added, 4 yellows here. Now yellow from the second box, 4 favorable out of 8. So now 3 yellow, and here again 4 yellows. Now you want to take out orange ball, 3 favorable out of 4. Sorry, 3 favorable out of 7. Is that clear? Simplify to get the required answer, my dear. Simplify this to get the required answer. So this is about dependent events, my dear friends. When the events are depending on each other, we need to understand how one affects the other. How one affects the other, we need to understand. Am I clear? So this is about problems on dependent events. See, just we are having 3 events here. How complicate the story? Assume it is like 4. Suppose you done 4 draws. Things would be very, very complicated. So you need to understand, remember this carefully. Okay. So here I am giving you, okay, anyhow, we solved it. Ignore that. I am giving you 2 very important homework problems. This is a very important problem, sir. I want you to try these 2 homework problems. Very, very important. This is one of the important questions for your gate point of view. Okay. If possible, tomorrow I start with this before, introducing Bayes theorem, because from tomorrow onwards we are going to start with the concept of total probability and Bayes theorem. I am planning to do it in 2 days. Let us see, 2 or 1 days I will try to finish it. If I extend the tomorrow session, tomorrow itself it will be completed. Otherwise I will take 1 more session. Am I clear? I just want to take up more questions on Bayes theorem, because for data science and artificial intelligence student, that is also naive Bayes algorithm. Am I clear? One of the machine learning algorithms, important. So I just want to see in that way also. Okay. So that may be extended in 1 more day. So that is the idea. So please try this important problem. You can write your answer in the comment box here if you already solved it. Otherwise, chat here or in the comment box. I request you to try this and write your answers in the comment box. What I try to do is, in our community, I try to post this quiz. Am I clear? This one and the next one. So that in that way, most people may be trying these problems. This is one more very important, interesting question. This is one more very interesting question, so which I want you to try. Okay. So with this, I stop today's session here. The problems on independent and dependent events. So in the next session, we start with the most important. Of course, the name of the topic would be Bayes theorem. But first, we start with the total probability theorem, because both are linked together. See, ultimately everything we are going to discuss, whether it is multiplication theorem, conditional probability, Bayes theorem, total probability theorem, they are all related to the concept of conditional probability. Okay, so that's all for today. If you have any other doubts, you can ask. Okay, so this is my Telegram group, Babu, CS_Sridhar. You can join here, where you'll be getting regular updates. This is my app. So in the app, you'll be getting the entire engineering mathematics, all the previous year questions solved with short notes, and also practice questions. All are available in MACSGATE app. And engineering mathematics now ₹15 per day. So you want to complete in 10 days, you can complete it, and it is rupees, I think around 40 rupees. I didn't remember exactly, around 40-45 rupees, I think 40 rupees maybe. Please check it out for 3 days. So I wish people to do this, like just purchase this course, because here I'll be giving only the concepts, maybe problems. There all the recorded versions are available, all the PYQs document is available. Okay, practice questions, short notes, everything is available in MACSGATE app. Okay, you can just download this MACSGATE app or MACSGATE website also. Okay, there you can get this courses. Now we only launched engineering mathematics, discrete mathematics for computer science students. Okay, those who are interested can take advantage. So we are mainly planning for introducing these subjects per day. Okay, those who are interested can purchase for day also. That's all for today. Thank you.